Hello everybody, welcome to the second chapter of this complete Java course for beginners. I'm Sergio Lerma, software architect, and today I will guide you with the so-called primitive types and their operations. And at the end of the video, you will be able to write some basic Cipher algorithms. As in the previous video, you don't need any previous knowledge, just some applications to be installed. Watch the first video of the playlist to install them. And today I have a new toy. I have a microphone. My wife nearly killed me when I bought this. Developers, they spend their money in such useless toys. I hope the sound will be better now. So here we go. Let's start learning Java. Subscribe my YouTube channel. First, you can download the project I am using in this video as following. Go to a terminal. Some people may love the terminal, some others may hate it. There is no middle point. I love it. And here, go to a folder to download the project. Here, write git clone and the URL of the project. Hit enter. I won't hit it because I already downloaded it, and then enter in the folder. Now you have to switch to the second chapter with git checkout chapter 2. Hit enter, and here we are. Let's go now to Eclipse to import this project. I already have it, but if that's not your case, just come here, import Maven existing project. Select the folder and import the project. When done, in the Package Explorer, just hit refresh to be sure to have the latest version. And you can see the contents. In the source main Java folder, all the code, and in the source test Java, all the tests. Let's now define a variable. A variable is a place in the Java virtual machine to store a value. And as its name indicates, a variable, the value can change. What kind of value? What kind of data can I store? We have two types, primitives and objects. The objects are more complex and I will dedicate another video to them. And the primitives, which is the topic of this video, which can be any kind of number like byte, short, integer, or long. It can be floating point numbers like float or double. We also can have characters, char, and booleans. Those are all the primitives, and they all start with a lowercase. That's important because it's the way to distinguish the primitives with the objects. The objects are more complex to use, so keep the lowercase for now. Eclipse also helps you displaying it in another color. So let's see how to use them. I start by the numbers. The default one is an integer. I have to define the type of the primitive, the name, which can be whatever I want, and then if I want an initial value, like 1. If I put the same number in another, it will be automatically cast into what's in the left side. Or I can cast it this way. But forget about that, the cast are for later. Default one is integer. But if I want a smaller number, I can use short or byte. And if I want a bigger number, a long. Bytes have a limit until 256, and the long have a limit about 20 digits, I think. I don't know how much millions of millions is that. With the floating point numbers, I have to include the dot. and the default one is the double. As you see, there is no error here, but I can specify the F or the D if I want to explicitly cast it into a double or into a float. The float has less precision than with the double. I think that the double can hold up to 100 digits, which is billions of billions. I don't know how to call this kind of number, like the number of bugs I make in my project. And then characters, which are letters in lowercase or in uppercase. You can even have symbols, or even some special characters like a new line, tab, or the Windows new line. But keep in mind, single quotes, always single quotes, not double quotes. No, not double quotes. Double quotes are for strings, for chained characters. Those are not primitives, those are objects. Those start with uppercase. Don't look at them. We'll see it in another video. You can have all the common characters and some special too, like the new line, the tab, and more. And finally, the Boolean can have only two values, true or false. As before, lowercase. Which one will you use the most? Booleans and integers. For the fractions, both values and doubles have some limitations. Use best an object if you want more precision, like big decimal. We will see why they have some limitations. And for the characters, at the end you will use most the strings, the chained characters, instead of single character. So from this video, the only thing you will use are the integers and the booleans. Here are some exercises. Just create the variable which is asked in the documentation, return it, and run the test with char in the source test folder, primitive tests. With the right click, run JUnit tests. If they are green, good. If they are red, keep trying. But what's behind that? Bits. Only bits, up to 64 bits. You know what's a bit, right? 0 or 1. Don't quit now. This is the base of the Cipher algorithm. A bit, it's a 1 or a 0, nothing more. The bits are the languages of the computers, a place in the hard drive where you can store an electronic signal or not. If you have 1 bit, you can count to 1. You have 2 states, the 0 or the 1. You can count more because there is no more numbers. If you have 2 bits, you can count until 3. 0, 1, 2, and 3. Because you have 2 bits. Still there? Still awake? Good. So, for numbers, it's easy. The more bits you have, the bigger number you can store. For characters, there is a list of upper and lowercase characters of almost all the languages with 16 bits. And the booleans are only 1 bit, true or false, 1 or 0. True equals to 1 and false equals to 0. And here comes the floats and the doubles. I don't remember how they calculate what's in the right part of the dot, but half of the bits are reserved to the right part and half to the left part. So why the floating points have limitations? Let's try to represent 1/3, 0.3333, etc, etc. If I have a limited number of bits, I can represent an infinite number of threes. Still blocked with the bits? Let's see an example of a binary representation. Make sure to understand them, because it will be easier to you to understand how an application works. Let's represent a number. Number 10. I have the powers of 2. 2 of the power 0, which is until 1. 2 of the power of 1, which is 2. 2 of the power of 2, which is 4. 2 of the power of 3, which is 8. Okay, so how to represent, how to obtain 10 with those powers? 10 is equal to 8 plus 2, which is 2 of the power of 3 plus 2 of the power of 1. So I have the 3 and the 1. The 3, not the 2, the 1, and not the 0. So this is the binary representation of 10. Hard now. I remember at the electronic classes they asked to translate a binary number into decimal. Life was easy then. Your turn. Here are some exercises to practice binary to decimal conversion. Read the comments to return the right values. And at the end, go to the test class, which are binary representation in the test folder here, and run them like this. Run GUnit tests. Green is good, red is bad. Try again until all are green. Now that you know that a number is written in a binary form but printed in decimal, let's come back with the numbers. The easy part. The math operation, do you remember that? All those headaches when you was a teenager? Here we are again. Two variables. Let's print the operations, the results. A plus B for the addition. If I run, I got 7. The subtraction with the minus. I got 3. Multiplication. We got 10. And the division. I've got 2 because they are integers. There is no floating numbers. They are both integers. And here is the modulo, the remaining, which is 1. If I divide 5 with 2, I obtain 4, but there is 1 remaining. If I want a precise division, I must have floats or doubles. Use the division again, and I got 2.5. Don't try the modulo with the floating points, it makes no sense. Those operations can also be stored in the same variable, like if I want to make the sum and store the result again in the same variable, I can change the symbols, plus and equal. Seven, because I made A plus B, which is 7, and stored with the equal again into A. So printing A is the result of the addition. I can do it with all the operations. The multiplication, the division, the subtraction, the modulo, all as before. And the last math operation, the last promise, is the increment and decrement. I can increment a by 1, five incremented by 1 is the result 6, and there is the reverse operation, the decrement. But there is two ways to do that. Let's see if I increment it in this way and in this way, and print a at the end. A starts being 5. Let's run the first operation, a plus plus. It will first print a and then increment it. The second operation, plus plus a. It will first increment a and then print it. So in the first printing, it prints a, 5, and then increment it to 6. In the second line, it first increment it from 6 to 7 and then print it. And at the third line, I only print a to see the value. Some exercises now, and I won't bother you more with the maths. Use the correct symbols to perform the correct operations as described in the comments. When done, go to the test, which are the test folder, math operations here. As before, right click, run JUnit tests. Make them all green. And before the base of the Cipher algorithm, one last thing, the Boolean operations. That's really quick. A Boolean, as I said, is a single bit, 1 or 0, true or false. I don't have arithmetic operations here, but I have some Boolean operations. B1 to be true, and B2 to be false. There is the Boolean operations, the conditional operations. B1, there is OR condition. I want the value of B1 or the value of B2 to be true. As I have B1 being true, one or the other is always true. And there is the AND operation, double ampersand. I need both variables to be true, to have the result true. So as you see, if I have one true and the other false, the result will be false. And the last one is the negate. I will negate the value of B1. If it's true, I got false. If it's false, I got true. And the final one is the XOR operation. This one may be the most difficult Boolean operation. It will return true only if one of the variables is true. Only one. If both variables are true or false, it will return false. Otherwise, it will return true. In this case, I have B1 being true and B2 being false, so the result is true. The other operations are the comparisons. A being greater than B, A being less than B, A being greater or equal, less or equal, different, or equal to B. It returns true or false. A being equal to B, it's not true, because A is 1 and B is 2, so the result is false. The Boolean operations are very important for two reasons. they will control the execution of a program with the flow control, and this is the first step for the Cipher algorithm. More exercises, I know I'm boring, but it's practicing you will learn better. Practice, practice, practice. That's the workout of your brain. Read the comments and run the tests, which are in the test folder, Boolean Operations. Right click and run tests. Finally, the Cipher algorithms. What are the Cipher algorithms? It's a way to translate unreadable information like a number, a word, in another number or in another word with a key. Then you send this transformed number or word to anybody, but they don't know what's really behind. They have to apply the same key in the reverse way to obtain the original value. The goal is to hide the original value when sending the data. How to implement a Cipher algorithm? Do you remember some minutes ago the binary representation of a number? Go back and say it again. Make sure you understand it and come here when you're done. Let's take the value 10, which in binary representation is 1010. Let's use another number, mask, which will be 6. In binary representation is 0110. This is the mask, this is the key. Now, if I apply the AND operation with a single ampersand, it means that apply the AND operation bit to bit, a bitwise operation. The result is 2. The binary representation of 2 is this one, because I applied the AND operation to all the bits. I have 1 and 0, the result is 0. 0 and 1, the result is 0. 1 and 1, the result is 1. 0 and 0, the result is 0. I can make the same with the OR operation. And I will have 14, which is this, because I have 1 here, I have almost 1 in the second column, I have almost 1 in the third column, and there is no 1 in the fourth column. And now let's use this strange XOR operation. I got 12, which is here. I have only 1 in the first column, the result is 1. I have 1 in the second column, the result is 1. I have 2 1s in the third column, the result is 0. And I have no 1s in the last column, the result is 0. Why the XOR is so important here? Because now I can apply it back. I have the number 12 and I have the mask again, and I obtain 10, the initial value. You can see it. If I use the AND operation, the AND bitwise operation or the OR bitwise operation, I can't go back to the original value. It's not the same with the XOR operator. It allows you to come back to the original value. This is the operation which is used to encrypt data to be sent to a receiver, and this receiver can encrypt it back to obtain the original value. The AND and the OR bitwise operators are useful because you can't go back. Why to use them? So let's go to a website where you have an account. You have to log in with your email and the password. For your security, I hope the website don't store the password. How many of you have a different password for your email account, your Amazon, your bank? Not many have a different password for all the accounts. So if one account knows your password, you're in trouble. It can log it into all of your accounts. Don't worry, the websites don't store the password. The good websites, they store a hashed value. Your password will go to an algorithm with multiple AND or operators, and they store this result. As you can go back to the original value, the websites won't be able to decode your password. Nevertheless, use different passwords for all your accounts. Not all the websites use this kind of encoding, but having a single mask is too easy to get back the encrypted information. So let's add more operations. The shifts, bit shifts. Shifts to the left 2 times if I want, which is 40. I have 10 and 40 is 2 shifts to the left. So I add the same number but shifted to the left 2 times. I can do the same but the right side. Shift to the right, so these numbers go 2 times to the right, which means 2. The right side is a variable. I can put whatever I want, 1, 2, 3 or whatever. It moves all the bits to the right side or to the left side as many times as you want. And now I can chain multiple operations. I can apply the XOR with the mask. I can shift to the left 3 times. Another mask if I want. And another shift. What's the result? I don't even know. Let's see. Okay, 55. But the interesting of having multiple operations is that the way to hack this is very difficult, because to get back the information I have multiple operations to perform. I have to repeat all the operations but in the reverse way. Before it was to the right 1, now it's to the left 1. The XOR operation is the same in both ways. 15. Now to the right. I hope it's the same value. It's 10. Yes, 55. And back to the original value, back to 10. This is the base of a cipher algorithm. Of course, the actual Cipher algorithms are very, very complex, not like this chaining for operations. I let you exercises below. Try to encrypt and decrypt the values as described in the documentation. When you're done, test folder bitwise, and here, right click, run JUnit test until this bar is green. Lot of work, right? One last thing before leaving. Until now, I've spoken about variables, only variables operations, about changing values. What about the constants? What if I want a value to never change? I have the final keyword. If I specify a variable with final, Java understands it as this is the final value. If I try to modify it by incrementing, you can see the red line just below. Error. Remove the final modifier. There is no way. I have to remove the final keyword because this is a constant. It's no more a variable. I don't know how to make a test with the final keyword, so there is no more homeworks. When done all the exercises, you can run all the tests together. Click on the name of your project, run JUnit test, and you should have the green bar. And if you are to struggle, come back to the terminal and git check out chapter 2 solutions. Make sure to reset what you have done before, and then check out chapter 2 solutions, switch it, refresh the project, and now you can run all the tests. Check if you want the solutions, but don't cheat. That's all. Replay the video again and again to make sure you understand those bases. That's really important. And if you understand this, the rest will be a piece of cake. Use the like button and subscribe. And see you in another video. Bye.